Hello, children. I hope you all are keeping fine and making use of every single second. We are going to start with a new chapter, and in this video, we'll be talking about spectrum. And in this video, we are going to discuss deviation, dispersion, and spectrum. So let's begin. Deviation produced by a triangular prism. When a light ray OP of single color enters a triangular prism ABC, it gets deviated, say by an angle delta 1, towards the base BC at the first surface AB of the prism and travels straight as PQ inside the prism. The angle of deviation delta 1 depends on the angle of incidence and the refractive index of glass with respect to air. On striking the second surface AC, the ray PQ gets further deviated, say by an angle delta 2, towards the base BC and travels straight as QR outside the prism. The angle of deviation delta 2 depends on the angle of incidence at the second surface and the refractive index of air with respect to glass. For the emergent ray QR, the total deviation delta with respect to the incident ray OP is given by delta is equal to delta 1 plus delta 2. The total angle of deviation delta depends on the following three factors. First, the angle of incidence at the first surface. Second, the angle of prism. And third, the refractive index of the material or the color or wavelength of the light used. So, the angle of deviation depends also on the color of the incident light. The light of different colors have same speed in air but different speeds in a medium. If the light entering the prism is not of a single color, that is, it is a mixture of several colors, then the emergent beam also has different colors arranged in a definite order. It is because the speed of light in a transparent medium decreases with the decrease in the wavelength of light. Therefore, the refractive index of glass increases with the decrease in the wavelength of light. Therefore, the deviation caused by a prism also increases with the decrease in the wavelength of light. In visible light, violet color is deviated the most and red color is deviated the least, because in glass the speed of violet light is least and that of red light is the most. The light of different wavelengths produce the sensation of different colors on the retina of our eye, so we perceive them as different colors. Wavelength is the characteristic of color irrespective of its origin. In other words, color is the subjective property of light related to its wavelength. In the spectrum of white light, the red color has the longest wavelength, nearly 8000 angstrom or 800 nanometer, or lowest frequency, and the violet color has the shortest wavelength, around 4000 angstrom or 400 nanometer, or the highest frequency. From the violet end to the red end of the spectrum, the wavelength increases while the frequency decreases. So we have learned that dispersion is the phenomenon of splitting of white light by a prism into its constituent colors, and spectrum is when white light passes through a prism, the band of colors seen on a screen.
Dispersion of white light by a glass prism. You must have seen and appreciated the spectacular colors in a rainbow. How could the white light of the sun give us various colors of the rainbow? Before we take up this question, we shall first go back to the refraction of light through a prism. The inclined refraction surfaces of a glass prism show exciting phenomenon. Let us find it out through an activity. If a prism is placed in a room and a narrow beam of white light is allowed to fall on one of its refracting faces, what do you observe? It is found that light coming out from the other face of the prism is split to 7 colors. What are the 7 colors that you see on the screen? The various colors seen are violet, indigo, blue, green, yellow, orange, and red. This phenomenon, the splitting of light into its component colors, is called dispersion of light. The band of the colored components of a light beam is called its spectrum. Why does this happen? The acronym VIBGYOR will help us to remember the sequence of colors. We have seen that white light is dispersed into its 7 color components by prism. Why do we get these colors? Different colors of light bend through different angles with respect to the incident ray as they pass through a prism. The red light bends the least, while the violet the most. Thus, the rays of each color emerge along different paths and thus become distinct. It is the band of distinct colors that we see in a spectrum. Isaac Newton was the first to use a glass prism to obtain the spectrum of sunlight. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get any more colors. He then placed the second identical prism in an inverted position with respect to the first prism. This allowed all the colors of the spectrum to pass through the second prism. He found a beam of white light merging from the other side of the second prism. This observation gave Newton the idea that the sunlight is made up of 7 colors. Any light that gives a spectrum similar to that of sunlight is often referred to as white light. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets act like small prisms.
Now let's find out the cause of dispersion of white light and formation of spectrum. The cause of dispersion of white light is the change in speed of light with wavelength. When white light enters the first surface of a prism, light of different colors, due to their different speeds in glass, gets deviated through different angles towards the base of the prism. Therefore, light of different colors present in white light follows different paths inside the glass prism and then strikes the second surface of prism. On the second surface of prism, only refraction takes place. That is, The different colors are deviated through different angles. Violet light is deviated the most and red the least. As a result, the colors get further separated on refraction at the second surface. The light emerging out of the prism thus has different colors that spread out to form a spectrum on the screen. We need to remember few points. First, dispersion of white light occurs only at the first surface of the prism. Second, deviation of light rays occurs at both the surfaces of prism. And the third, the prism does not produce colors, but it only splits the various colors present in the light incident on it. So this was the discussion on visible spectrum. But children, have you ever imagined that there could be something beyond the visible spectrum? Is it? So why don't you work on it? Check, and we'll be discussing this concept in our next video. Till then, goodbye and take care. God bless.